Microprocessors.
Okay. So you have gone through the material which was given?
Yes, ma'am. You follow the material.
Last time in the material, there is block diagram was not there. Did you see that block diagram was not included in the PDF which is given?
Yes, ma'am.
So could you find that block diagram somewhere, or again you want me to give that block diagram?
No, ma'am. You send the PDF. That only we have to follow, ma'am.
No, in your material also one block diagram is there. The one which I was showing you on the in the class, that was little simpler. So I thought that you people also can do that simple block diagram in the exam. That would be enough.
Yes, ma'am.
So okay, today I will see where that file is and then I will send that. You draw that one for the exam, because in the textbook it is little complicated. So I thought some simple block diagrams, if you will have, it will be easy for you to do in the exam. With that
Yes.
intention only, I am looking for little easier things, because drawing big block diagrams and then they are connected by buses. So you have to show the connections also. Then only that block diagram will have meaning. Okay, then today we have to learn something about 386 processor. So last class we have seen 80286. This class we will see 80386 processor. So one by one, as the weeks are progressing, you have been learning through the advanced processors one by one. So 386 also is another advanced version of the processor. Now advanced means we want the speed of execution should be more. We want larger memory. These are the two things which generally people will focus. They will look for either larger memory or they will look for a higher speed. So now how 386 will be an advanced version, that we will see. I will share my slide here. So initially, before we start with our block diagram, what are the features of 8086, because of which it has become an advanced version, that you can see one by one. So just now, as I said, 80386 is an advanced version or the upgraded microprocessor. From which level it is? Upgraded from 8085, 8086, then 8186. 186 we did not learn. So 8286. Now it is 8386. So see there, it has 32 bits of microprocessing unit. So earlier what we have seen, the microprocessing unit was 16 bits only for 286, if you remember. And 8085 it was only 8 bits. So when it comes to 386, 32 bits means from 8085 till 386 it has increased 4 times. And so it can operate with 32 bits of data in a single machine cycle. So you have to note this point also, that it can work with 32 bits. Means if you are adding two numbers, the two numbers are of the size 32 bits. So at a time you can add 32 bits together. So 8085, if you have done in the practicals also, if you are having more than 8 bits, means first you have to add the lower 8 bits, and then if there is a carry from the sum, then that carry is added along with the higher 8 bits of the two numbers. That is how it was working. So in this process, what happens? The program will become big. Number of instructions in the program will be more. And as a result of it, it requires more number of machine cycles also. So the time which is needed to execute that particular program when it was 8 bits will be large. When it becomes 32 bits, in one machine cycle, it is possible to add the two numbers whose length is 32 bits. So I think you can understand this point, that in a single machine cycle, the operation which is to be performed on the two numbers will take place. So it is very fast when compared to your earlier versions. So in the last class also I said, when you are going to buy any laptop also, you will see the laptop how many bits it is. So what is the speed of the laptop, 64 bits or 32 bits or 128 bits. So like this, you will, that is given a particular name there. So depending upon that, the execution of that processor will be, or that particular laptop will be, or even your cell phones also, which are doing all such calculations. Now, not only the microprocessor, so in that microprocessor, if it is 32 bits means your arithmetic logic unit also. Obviously, microprocessor is consisting of your arithmetic logic unit. It consists of the different buses in that. So the size of the bus also will decide the speed of the processor. So the arithmetic logic unit, obviously, if it is performing the operation with 32 bits means arithmetic logic unit also should be of your 32 bits capacity. Then in the last one also you have seen 286 processor. There it was having separate data bus and the address bus. So here also it is having 32 bits of data bus and 32 bits of address bus. Now, one point which you have to note here, it has 32 bits of data bus, means there I have written that it has 4 level of memory banking. Now, what does this mean? 4 level of memory banking means, um, you imagine you are having a single line notebook, and on a page when there are lines, what you will do? On each line you will write, is it not? So on each line, how much space is there? That much only you will write. Similarly, for a microprocessor also, the whatever data you are giving in the program, when it is saved in the memory, it will save only 1 byte. Only 8 bits can be saved. Now I am saying here the two numbers which on which the arithmetic or logical operation is to be performed, or if the execution has to take place, the logical and arithmetic operations, if 32 bits of both the numbers are to be added at a time, then it should get that 32 bit length to add simultaneously. But your memory will save only 8 bits in one location. It is like in a house, if you are having one room, then you will use only one room. If you are having two rooms, you will use two rooms. But for the memory, when the number itself is of length 32 bits, how it should accommodate that 32 bits? That 32 bits, it will accommodate in the size of 88 bits. So if it has to take 32 bits at a time means 8 bits in one memory, another 8 bits in another memory location, another 8 bits in another memory location. So like this, it will have 4 level of memory banking. So you can imagine that you are having 4 different RAMs, and you will take 88 bits from each RAM, and the total length of 32 bits will be then satisfied. Now, similarly, in the address bus also, it has got 32 bits of address bus. So in this, you can have 32 lines of address. So it will have 32 bits of address. Now, here also, last time also I asked you, how much will be 2 to the power of 30? Calculate and tell me how much is it going to be, 2 to the power of 30. So we have seen till 2 to the power of 20. last time I think. So now how much is 2 to the power of 30? How much is 2 to the power of 40? Calculate and tell me how much it will be. Depending upon that, further I have to tell you something. Two to the power of 30 and 2 to the power of 40. Now we want in terms of bytes, kilobytes, megabytes. Somebody is doing? There is no response. Okay, I'll tell you, you make a note somewhere and keep. We will come across such points little later again. 2 to the power of 30 will be 1 gigabyte, BYTE. 2 to the power of 30 will be 1 gigabyte and 2 to the power of 40 will be 1 terabyte. 2 to the power of 40 will be 1 terabyte. Now 32 bits of address bus means 2 to the power of 30 itself is 1 gigabyte. And then another 2 bits means 2 to the power of 2 will be 4. So 4 gigabytes of memory is possible with the existing address bus. Make this point, note it somewhere and keep. I'll come back to that point again here. Now, as I said in the beginning of the class itself, that the speed increases depending upon how many number of bits can be operated at a time. So 32 bits, that is your data bus, was determining speed in one way by which the speed is increased, and then the clock cycle, the crystal oscillator frequency, this also decides the speed of the processor. So in this 386, we were having the clock frequency of different values starting with 16 megahertz. So different speeds of the clock was available. Now different speeds means different companies when they are manufacturing the same 386 processor, some feature will be different in each of the company product. So in this way the clock frequency was different. So some were having 16 megahertz, some is having 20 megahertz, 25 and 32. So it is starting, 386 is starting with 16 megahertz. So earlier we have seen the clock frequency was about 8 megahertz. So see how much it has increased in this case. So higher the clock speed, it gives the higher speed of execution of the program. So the data bus as well as the clock, both of them have increased. So naturally it is an advanced processor. So both the criteria by which the speed of execution of the program increases, these are met in the case of 80386. Now, another interesting feature which you will see about 80386 is it is available with single speed and double speed version. Now, generally it will be designated as SX and DX. These were the two different versions. Now, what is single speed and what is double speed? So, as you can see in the PDF itself, single speed we have 16 bits of data bus and double speed we have 32 bits of data bus. Now, where was the necessity to have a single speed and a double speed version of 386? Now, see here, you will also see little later when you come across the block diagram and some features of 386. It is having some special features apart from the speed of execution. So in that you will see that all those programs which were written for 8086 processor, you can still execute them using 386 processor. Now, difference between 8086 and 386 was with your data bus. One of the major difference was with the data bus. 386 is having a 32-bit data bus, whereas 8086 is having a 16-bit data bus. But then, if we want to upgrade our system, you can replace that 8086 microprocessing unit with your 386, keeping the bus size as it is. So did you get the point? We can replace only the processor. So we will get some of the features of your 8086. You can have a little advanced version. But the data bus, which was 16-bit, will remain as it is. Now, 32 double speed means as it is 386 system only. So naturally it will come with 32 bits of data bus. So all those programs which were written with 8086, if you want to upgrade your system, you can still replace the processor 8086 microprocessing unit, and you can keep the data bus as it is. That is why we call it single speed version and double speed version. So single speed version is upgradable from 8086 to your 386. So this is one of the features that they were having with 80386. Now, another interesting point here with 386 is it supports 3-level pipelining. Now, last time only I told you how the 286 had the fastness of execution was increased in the 286 system. There you had 2-level pipelining. Here it is 3-level pipelining. There for you fetch and decode were taking simultaneously and execution was taking in the next cycle. So here for fetching, decoding and executing, you are having 3 different blocks. So that is why it is known as 3-level pipelining. So simultaneously, so once the instruction is fetched, that will go to decode. Now in that place, one more instruction they will fetch and then they will send for decode. So like this, the instruction which was decoded will be executed. So one by one, the process is going on continuing. So we call it as 3-level pipelining. Earlier what you have seen was only 2-level pipelining. And then you had one instruction queue also in that. So that 6 bytes of data were already fetched and kept ready. And then it was executed. So in this case also you will see you will have instruction queue and then prefetch queue, all those things. So you will more than 1 byte you can fetch it and keep it ready for decoding and next execution. So it has got 3-level pipelining. Now it can have maximum of 64 terabyte of virtual memory. So if you want to increase the memory, then you can increase up to 64 terabyte of virtual memory. So see there, in all the block diagrams, we had some memory, internal memory, which can be used when you are executing the program. Now, in all our computers, you know that you had what is known as a hard disk. So hard disk is like a virtual memory. And whatever memory is associated with the microprocessing unit was your main memory. So you can have a maximum here with of 64 terabyte of virtual memory, and that memory, if such a big memory is there, so big programs will need a larger memory space, so you need to have more memory there. But to access the data from that such a big memory, how do you keep track of that data? So there comes the memory segmentation. So segmentation we have been seeing from 8086 only. Your code memory, stack memory. So all those segments which you had, that is nothing but memory segmentation. Now, three features which were very important with 386 is it supports paging. So because of the memory segmentation feature, it was able to support paging. And paging is nothing but that whole memory will be divided into small blocks, and that each block they called it as page. So that is what is known as, that mechanism is known as paging. So it supports paging, then it has a protection mechanism, and it supports multitasking. So in this way, you will see that 386 was much ahead of the previous processors. Not only the execution speed, but the design itself was such that it got it could interface a larger virtual memory. It could provide a paging mechanism. It could provide a protection mechanism. It supported multitasking. Now, and if the older versions were there, that also you could upgrade with single speed and double speed type of designing. So these are all the features which 386 was providing. So you can see suddenly there was a boost in the working of the processor. So now we will see the block diagram. This also is very simplified block diagram, unlike the one which is given in material. So in this, you can remember those different blocks, and each block's name I have given in a red color. So you can see in this, you are having execution unit is separate, segment unit is, this is because of the memory segmentation, you had a different segment unit and a page unit. Now this paging which feature which is available with 386, it is not necessary you should use that particular property of 386. If you want, you can use. If you don't want, then there is an option how you can discard that particular property of 386. So only one bit is there. Some PE bit will be there in a control register of 386. If PE bit is 1, then the paging is supported. If it is 0, then you can simply overlook that particular property. So that is how paging unit or the paging was optional with 386. Then you are having bus unit. Then as we said, it has got 3 level of pipelining. So for 3 level of pipelining, you can see here very clearly in the block diagram. You can also remember in that way because it is having 3 level of pipelining. You are having separate prefetch unit, separate decode unit, and a separate execution unit. So it is very easy to remember this block diagram because of the, if you remember the features, then you can easily draw this. Now bus unit is always necessary because it will manage or it will control all the different buses or the control bus of your processor. Now all the different type of buses which the processor will look for is your data bus, address bus, and the control bus. So it will control the operation of all these buses. So bus interface unit, earlier also in 8086 you had a bus interface unit which was interfacing the memory as well as the IO devices or peripherals. Here also it is the nature of work is the same only for bus unit. Now because of the memory segmentation, you are having 2 units, segment unit and page unit. So if you remember the features, once again I am repeating, it will be easy for you to draw the blocks as well as to write about the architecture of or the block diagram of your 386 processor. So one by one each block you can see the bus interface unit. So it controls the system bus of 8386. So just now I said by bus or system bus. And system bus is a more appropriate word when you are talking about the system bus of any processor. So system bus, it will mean data bus, address bus, and your control bus. So by control bus, it means all the different controlling operations. Read and write also will come in your control only. So if you have to read something from the input device or write something to the output device, then you have to send that particular data or receive that particular data from that particular peripheral. So it controls the system bus of 8386. So how much was the system bus in this case? Mainly your data bus and the address bus. Each one of them is of 32 bits. So it controls your 32 bits of data bus as well as the 32 bits of your address bus. Now, address bus will be unidirectional or bidirectional? Till now, if you have really read about the processors, this point you should be able to answer. Address bus is unidirectional or it is bidirectional. Data bus is unidirectional or it is bidirectional.
Address bus bidirectional.
If you say it is bidirectional, can you explain how can you tell it is bidirectional? Okay, then if okay, somebody else can give the answer whether the data bus is unidirectional or bidirectional.
There is two directions. Bidirectional means.
Yes, bidirectional means there are two directions, both input as well as output. By bidirectional, we mean input as well as output. Unidirectional means it will go only in one direction.
Either input or output.
Yes.
Ma'am, address bus is unidirectional and data bus is bidirectional.
Super. Is it Geeta? Super. Yes.
No, ma'am, Chanchal. Yes.
Chanchal.
Okay, Chanchal. Good. Very good. So, address bus is always used to give the address of location from where the data has to be taken. So that is why address bus will always be unidirectional. It is only used to give the address. Data bus means, see in your program, in the instructions itself, the data will be present. So the data, when it is coming from any input device also, it will be saved in the memory. And after it is executed, see if you are adding two numbers, you have to give numbers from your keyboard only, is it not? It will be saved in your memory. After adding, result has to come out no again. So that is why data bus, it will take data from the memory and again it will give data to the memory. Result it has to show somewhere, no? It is taking from input device and giving to the output device. Where it is being stored, it will be stored in a location, and that location address, when you are writing the program, you must have written some addresses, no? In the lab, what you have done, if you try to recollect, when you are writing a program, you must have started at particular memory location.
Yes, ma'am.
So when you start, that memory location will also be fed. You were given the, you were also giving the memory location, no? You will
Yes,
start.
ma'am.
You will say memory substitute or something. You will say when in the lab also, when you will give there, you will give some 3000 or 2000 something. You must have given like this. So 3000, 2000. These are all memory location address. Opcode and operand are part of your program, but where it is going, you will give that location. From there it starts in the upward direction. So see, don't confuse much. I was trying to relate this to the practical switch. But if you start writing on a notebook also, first page, after filling the first page only, you will go to second page. After that only, you will go to third page. So like this, one by one, it goes on increasing. So address bus will always be unidirectional, data bus will always be bidirectional. Because after two numbers, best example I am taking is if you add two numbers, the result you have to store in the memory location sometimes, or you have to show it on the monitor. I told you in the last class also, if you are giving it on any output device, whether you have to give it to the printer or you have to give to a fax machine or you have to give to a monitor, the address of the output device should be given, then only that particular result will go there, no? So all the peripherals which are connected also will be given some particular address. So next, it controls your bus interface unit everywhere. See, whichever processor is there, please remember this point in a common way, that it controls the system bus of 8386. So now addressing of the memory and IO is done. The same thing which I was explaining all this time. Addressing of the memory and the IO device is done by your bus interface unit. Now, one point is true that addressing of the memory and IO device is done by the bus interface unit because it is connecting the memory and IO device. The microprocessor or the MPU is connected to the memory and IO devices for execution of the program. So from where it has to take the data, that will be given by your bus interface unit. Now it gets a request from prefetch unit for fetching the instructions and from execution unit for transferring the data. So it is very clear here, your instruction is having a operation code as well as an operand. So prefetch unit will be asking for instructions, and execution unit, since it has to work on the data, it will ask to transfer the data. So there are two functions here which are taking place. So the request is from prefetch unit as well as from execution unit. In the block diagram, you can see your prefetch unit is one block and execution unit is another block. So both of them will place the request to the bus interface unit, and if both the requests are received simultaneously, first it will give priority to the request from the execution unit, because it has to operate on the data. Even if your operation code is fetched in the prefetch unit, after decoding, then whatever data it needs for the operation, it will ask that data. So the execution unit request will be attended first. Now, what is the work of your prefetch unit? The prefetch unit fetches the instruction in advance to implement pipelining. So this is very simple. We also know that since it is 3-level pipelining, it is fetching the instruction. And how many bytes are fetched? It fetches 16 bytes. Now in this prefetch unit, in the block also, you can see prefetch queue, prefetcher. So prefetch queue will get at a time 16 bytes. So I told you that memory location can save only 1 byte, but the machine cycle, in one machine cycle, 4 bytes will be taken at a time because it is 32-bit processor. So if it is prefetching, 16 bytes means 4 instructions has to come at a time into the prefetch unit. So it fetches the next 16 bytes. In the earlier 286 processor, your instruction queue was 6 bytes there. Here it is 16 bytes of program. It is prefetching in advance and it stores in the prefetch queue. Naturally, if the prefetch queue is there, means the saving will be done in the prefetch queue only. And as that prefetch queue gets empty, so once 4 bytes are coming out of that prefetch queue, means again it will reload with 4 bytes in advance and keep, because it has 386 has 32 bits of data bus. Now, another interesting point here which you have to note is when branching is taking place. So in the programs which you have done in the lab also, if you have done some program which was having a branching instruction, you will say call so and so memory address. If you say, then in such a situation, you have to deviate from the main program. You have to go to that particular address and you have to execute the subroutine. After the execution of the subroutine, it will, in that subroutine, return will be there. Then it will come back to the main program. So in this branching, what happens is the next instructions which were saved in the prefetch queue, they will not be of use, because one by one it has to prefetch, then decode and execute. That cycle will be there for everything. But if branching is taking place, means it is going to some other location, it will execute those instructions, and when the subroutine says return, then it will come back to the main program, and again the main program will be executed. So in such a situation, what happens is all right instructions which were saved in your prefetch queue, they will be of no use. So it is discarded, it is said. So this happens one more time, not only in the prefetcher, but it happens also in the decoder. That also point you can see here. So I think prefetch unit is clear for you. It fetches the instructions in advance, and how much it is fetching? 16 bytes. And it stores in the prefetch queue and refills the queue when 4 bytes are empty. Means always your prefetcher will be full with 16 bytes. Because 386 has 32 bits of data bus. So that is why it is able to load again with your 4 bytes. Because instruction execution also will take place on 32 bits. Now during branching operations, your instructions in the prefetch queue will have to be discarded because they are invalid. Because your subroutine execution has to take place. Now, after the prefetch unit, you are having the decode unit. Now, in the decode unit block also, you can see you are having decoder and instruction queue. So, from the prefetch queue, it will go to decoder. It is decoded, and then it will wait in the instruction queue again. And from the instruction queue, you see the arrow is going to your execution unit. Now make a note of all those different blocks which are there in the execution unit. It is having registers, it is having barrel shifter. Then for multiplication and division, there is a separate circuit which will carry out the multiplication and division of 32 bits. And it is having an arithmetic logic unit. So registers will be needed because it has to temporarily save some data. Barrel shifter is, see, when you are doing manually the multiplication, so you go on shifting one position to the left, is it not? So if you are multiplying two numbers, the first number after multiplication will be written same way. The next number you will start from the second place filling up. So that is the work which the barrel shifter will do here for a microprocessor. So your decode unit, as just now you have seen in the block diagram, it has a separate decode unit for decoding the instructions, and it decodes the next 3 instructions and keep them ready in your decode queue. Now again in this also, during branching instruction, in the instructions in the queue will be discarded as they become invalid. So in the prefetcher as well as in the decode unit, in both the places, if the branching is taking place, the next instructions will become invalid. Now next is your execution queue. Now in the execution queue, just now I showed you, you had registers, barrel shifter, and for multiplication and division, to carry out those 2 operations, you had a separate block itself because it is doing multiplication on 32 bits. See, if you are multiplying two bits, let us say 1001 and 1010. For 4 bits I have to multiply. Every time 1001 will be multiplied with the least significant and you will write in one place. Next, it has to shift in the second position. Next, you have to shift to the third position. Next, you have to shift to the fourth position. After shifting is taking place, again you have to add all those bits one by one and then come to a final result. So execution unit is naturally executing the instructions. 32 bits of ALU is there, which performs your normal arithmetic and logical task. And it has a dedicated circuit for 32 bits of multiplication and division. Operands are given in the instruction, or it can be taken from memory. Now, if you see the instructions also, some instructions, as you have seen in your 8085 also, directly the accumulator can have the result, or you can say STA, store accumulator content in the memory location 3050. STA 3050H means it will store the contents of accumulator in the memory location 3050H location whose address is 3050H. So like this, the operands are either given in the instruction, or instead of STA, if you say LDA, then you are loading the accumulator with the contents of memory location. So like this, you are having instructions in which either the data will be given directly in the instruction or you have to take it from the memory. So if you have to take it from the memory, then the execution will send a request to your bus interface unit to send the data from that location. So operands are given in the instruction or it may be taken from memory. Now see, all these processors, when you are studying, first you go through the features. It is also possible that they may ask you, compare the processors. Then if you know the features, then you can write the features for those processors and that will finish the answer. At least if it is in the 5 marks, try to write 5 different features of each of the processor. That is enough for you to get full marks for that particular answer. So operands are given in the instruction or it may be taken from memory. It has 32 bits of flag register. See here, this point to be noted here. Flag register is also of 32 bits. So whenever you are doing arithmetic and logical operations, then the flags are affected. That also you know very well. And because of that, each processor will have a flag register. Now, in this case, it has got 32 bits of flag register, 64 bits of barrel shifter. Now, 64 bits of barrel shifter means, see, when you are doing multiplication of two 32-bit numbers, then you have to shift them, each one towards the left. So, that is why the barrel shifter is 64 bits, which provides a faster shifting during multiplication and division. It shows the control and status of the program. So execution unit will also show the control and status of the program also. So each unit, they have got their own individual work to do with different features included in the each unit. Now, next one is your memory unit. Now, memory unit, earlier only I said, because of the memory segmentation which is taking place, it has got 2 blocks there, segment unit and paging unit. So segment unit is having its segment registers and segment translators, and the page unit is having translation look aside buffer and page translator. Page unit in itself is one big topic again, how the pages are seen and how the address will be taken up when you are doing this memory segmentation. So there is something which is known as linear address and physical address. One more topic is there. So I'll come to those points little later. So memory unit, you have to talk about the segment unit and the page unit. It is a combination of segment unit and the page unit, although we have put in a different block there, segment unit and the page unit, but it is a combination. This memory unit itself is a combination of these two blocks. And the address bus was 32 bits. With that, you could have 4 terabyte. But here you can see it is possible to interface 64 terabytes of virtual addressing using segmentation and paging. Now, segmentation is it is needed, but paging is optional. So I told you in the control register there is one bit, PE bit. So I think, I don't know whether your material they have given about the control registers. 1 minute, I am checking that. It is only to get an idea whether you read or no is optional for you again. Control registers is there. It is there. Some figures are there on page number 274. This bit is PE bit will be in CR0. Here it is PG, it is bit number 31, it is CR0. So segmentation is needed because it also increases the speed of the processor, but paging is optional, means if you want you can use, otherwise you can leave it off. These computer people also will be knowing about the paging parameters. If somebody has done that BCA or BBA course, something like that, degree. Now segmentation, this point you can simply remember here. The segmentation converts the logical address into linear address, and paging converts the linear address into the physical address. So if linear address is physical address, then paging is not required. So these are few points which you try to remember like that only, because in itself it is a very big topic. I tried to see and tell, but I think it will not be enough for me to tell all these things. Like the time is not so much. So what I have felt is, instead of going much into the details of this, some few important things you can also see, and try to see the features of the processor, so that if there is a comparison of features, a question in the exam, you can write those things, highlighting about the data bus, address bus, speed of the clock, and then what features are different in one processor and the other processor. With this, it can cover 5 differences, is enough for your 5 marks. So they will not ask you that question in a long answer. It will be a short answer only. Now, this point, protected mode. So what are the different modes in which your 386 functions? For this, you have to know about the different modes. Now, there are 3 different modes in which your 386 and the protection mechanism I told, 386 has got 3 variety of features, like 3 very good features. That was because of the memory segmentation. It is possible to have segmented memory. It was possible to have paging, then protection mode, as well as one more was multitasking feature. So multitasking feature was also there with 286 also, if you remember, or you can go back and see my notes also. Now, what is all these different modes? That is what we have to see. In the last class, I told you, when you are starting your system, initially the processor 286 also, and now 386 also, it will be in 8086 environment, or it will be in 8086 mode. And when it is taking time to boot, when your laptop or cell phones, generally we don't switch it off, but if we try to switch off and then switch on also, it will take some time. So we say the processor is booting. Now initially it will be in the 8086, and it takes some time when it boots up. You can also call it as the setup time of the processor. After coming out of that setup time, it will be perfectly in your 386 mode. So initially it will be in the real mode. That is what we say. When you start, you reset your system or you switch on the power. So you will call it as reset or power up. So you can see this figure. It is very beautiful, I felt. Initially, when the system is reset means it will try to start once again from the beginning. Or when you are switching off and then trying to switch on, or you can call it as power up. So these are the technical words which you have to use when the system is reset or it is powered up. Initially, the mode in which it will be 8086. That mode we call it as the real mode. And once it is set up, or after the system it goes through the booting up process, then it will come in the real 386 or 80386 environment, and that you call it as the protected mode. Now, once it is set up, then automatically the PE bit will become equal to 1. Once your processor is in the 386 environment, the PE bit will become 1. Now, so when the PE bit is equal to 1 and it is in the 386 environment, that becomes your protected mode. Now what is the use of having the real mode there? So in the real mode, it works like a fast 8086 mode, because here your system clock speed is more. So that is why it will be in the fast 8086 mode. And in this mode, it works similar to 8086 it is. There is a mistake there, which was not corrected later by me. And it is used to set up the environment, 386 environment. To set up that particular environment only, the real mode is existing. Now, in the protection mode, just now what we said, once the environment is created by the real mode. So see there, it will not directly come to 386. It has to come through the real mode only. And the P bit has to become equal to 1 in the control register. So from the real mode, when the environment is set up only, it will work in the full 386 mode. Means in that mode, in the protection mode only, all the features which were designed for your 386 will start working, like segmentation, paging, protection, multitasking, all these different features for which it was designed, they will be active when it comes in the protection mode. Now, what is your virtual mode? That is the next thing. So, VM86 mode, it can be enabled in the protection mode by VM flag bit set to 1. So here, a VM flag bit is also there, VM flag bit. So it should be in your flag register. It is there in your flag register, one of the bit there, virtual mode it is. So in this, whatever programs which you had in 8086, that you can still execute them in the 8386 environment. So that is why the virtual mode is also there in your 8386 processor. Now, if you want to work in that, or if you want to execute the programs of 8086, then your VM flag bit should be equal to 1. And you can make this VM flag bit equal to 1 only when your processor is in the protected mode, is it not? So since 386 has got a flag register of 32 bits, and in that one of the bit is representing your virtual mode. So if you remember very well, your 8085 processor or 8086 processor, you had flag bits like carry, auxiliary carry, parity, sign flag. So similarly now VM is also a flag in the flag register. So when you make it to equal to 1, then only the programs which were written for 8086 can still be executed in your 8386. So this was a new feature which was available. So sometimes I think not about the virtual mode, but regarding the real mode and the protected mode, they have asked what is the protection mode in your 8086. So if you have to write about the protection mode means initially you have to discuss about the real mode and then come to your protection mode. This is what you have to do. So this much I thought I will tell you on this 386 processor. So if you see your material, their real address mode it is given. The discussion is real address mode, protected virtual address mode of operation. So if there is some more points which are there in that, if you are able to reproduce those things, then that also is enough. Otherwise, this much you have to tell in any way. These points at least you have to write.
Ma'am, send this
Yes,
PDF in the group, ma'am.
I will send every time I am sending. It is not that I am not sending. Every time I am sending.
This is somewhat different from my material, ma'am.
Yes. Different means see when your syllabus is so much. I myself keep wondering how you can write in the exam because and there is so much of complexity also in that. So I thought that little easier things if you can read and write, that will be better.
Yes, ma'am. All that much matter we can't
Yes.
remember in my memory in the
Yes.
examination.
No, for
Somewhat only we have to remember.
yes, that is why
We
in the
have to
beginning.
learn about 20 sentences. At that time exam only we have to remember and write only
That
5
is
to 7 sentences only.
yes. That is why you see I have made all the processors very simple for you. You try to compare and read. So all my PDFs are having features of the processor. So those features you try to put in some tabular column and read like that. Then you can remember how one is different from the other. I know all these things. I can also understand the psychology of the students, how it is possible, all these.
Yes, ma'am. Thank you, ma'am.
So that is why I'm also trying to give you some brief information that so much is there and advanced processors in itself is one big topic. It is not so simple. So that is why what I have asked the students in the class also, I was telling you try to read some 65 to 70% of syllabus such that you can answer your questions. See, nobody can remember 100% because the syllabus is so vast. Nobody can remember and you're all working people. If students means that is a different thing. For working people, so much it is very difficult at a stretch. If it is something like a semester, then you will have syllabus which will be divided under 2 semesters. So that is why you choose topics which you can reproduce. Like that you choose. Now again in this 486 and 586 are also there. I will advise, I don't know, it is your choice, but this much you try to read 386. I will see for features of 486 also and I will give that, I will add that part in this PDF, features of 486 processors, and then I will give you this PDF because it is likely that there may be a question that compare the features of 386 and 486. So because I have seen one question like that, compare the features on. So you can highlight 5 features of this and 5 features of 486. 486 I will include the features and I will send you this PDF. But for that it will take time or maybe tomorrow I will give. If not now, today in the evening. Or in tomorrow's class, I will send this and give in tomorrow's class. Because in spite of telling also, people are like, I may not give or what. See, nothing to do. I am also taking the material from your textbook only. There is nothing which I have designed or I have done something. There is nothing that I should not share with you.
Ma'am, will you please take one class on programming, the TLP programming?
Which programs? 8085 programs you want?
Yes, ma'am.
See, should I tell? I see. It is not a problem for me to take a program. Generally, very small programs will come, and I doubt they will ask you to write a program for the. See, only critical programs are largest number and ascending order. Those
Yes, ma'am.
those two are only critical. Otherwise, the other programs are very easy. This is what I felt. If you want, I can take. That is not a problem. But how will you understand in an online class? I have to only explain the instructions, how it is, how they are put. Will you understand that? If it is a offline class, if you want, I will tell which programs you want. Addition and subtraction, they are
Yes,
all
ma'am.
very.
Addition, subtraction,
See what they may ask. I have seen somebody has put some question papers. Check which programs are there in that. Anybody is free now itself, you check so that tomorrow we can discuss.
Actually, in practical classes, we have done, just it will be a revision for us.
Which program you want? All programs or only specifically some program?
No, ma'am, like that exams is coming, no, mostly that some and taking the largest number from the array.
Wait,
Like
in your material, what is there? I will see. Wait. See, if at least some 3 to 4 people want, means it is okay. If only one person.
Find the largest number in a given set of data array and explain with a flow chart.
Yes, ma'am. All are also want, ma'am, that programs.
No.
You can explain.
See
ma'am.
one thing. You check once the old question papers and see which program is repeated most times. Or we will discuss two programs, addition of 3 numbers. And see, when you are dealing with more than 2 numbers, means it will have a counter. 3 numbers, if you are comparing A, B, and C, if you are comparing 3 numbers, let us say A, B, C. So initially what you will do, if you are trying to choose the smallest number, let us say smallest among 3 numbers, A, B, C. So first you will compare A and B. Among those two, which is small, you will put that in your accumulator. Now that number in accumulator is compared with the third number. Among these two, which is small, that you will put in the accumulator, and you can check the result in the accumulator for the smallest number. And which one is smallest will be decided by your branch instruction. Are you following what I am telling? If you
Yes,
want,
ma'am.
if you want, I will tell that. That is not a problem. But generally, it is like this.
Ma'am, 3 questions are repeated, ma'am. Multiply of two 16-bit number and select the largest number, and addition and subtraction. 4 are repeated.
Last time, which one has come? Okay,
The
then.
sum of series of 5 8-bit numbers.
This I told in class. Some of the series of 5 8-bit numbers, if you remember. I remember very well, but I don't know about you. Okay, we will discuss. See here, tomorrow we will discuss addition of 5. We will not go much in complication. If I'll tell for 3 numbers, you can change the counter from 3 to 5 and do the addition.
Okay, ma'am.
I will tell you at which point you have to change the counter. At that point, I will tell. And then according to that, if 5 numbers are coming in the exam, you can do that. And that flow chart is there in the book called RAM. RAM. N-RAM or something is there, no, Geeta?
Geeta is not there, ma'am, today. She could not join today.
Yeah, I saw her on the...
Yeah, initial she was there, but she left.
okay, that flowchart. Okay, I will show the flowchart also tomorrow. So tomorrow's class will be last class then. If you want, see, programming, if you are doing whichever topic you are deciding to write the answer, you should study in such a way that whatever question comes, you should be able to do it. If you like this, you have to study, then only it is possible. It is not that you are studying 100% and you are not able to write that, attempt that question. Decide for yourself, choice is for you only. It is nothing. And one more I wanted to suggest you is this. In your syllabus, semiconductor memory is one topic is there. See the contents page. Are you seeing?
Yes, ma'am.
I'm in the
Block 2, ma'am. The block 2.
Block 2, yes, block 2. I felt that compared to your other topics like 486 and 586, at least you try to read classification and characteristics of memory. That will be easier for you.
That one complete.
No, classification and characteristics of memory we did not do. I did not do at least. So it is a theoretical. If you can read, fine. Otherwise, you can leave it. Classification and characteristics of memory. You try to see that if possible.
This is easy only, ma'am. RAM, ROM.
Yes. So that is what I wanted you. You read that so that you can attempt some questions from that topic. No, some easy topics if you take, it will be easy for you. This is what is my suggestion. My suggestion only. Choice is again with you only.
Okay, this one I have completed.
Achha, okay, one more point. You tell me, are you still remembering the instructions of 8085?
Yes.
And then, because tomorrow if we are doing that programming, you should be familiar with the instructions, or at least some 5-10 minutes you see the instructions, so that when I'm explaining, you will understand that what I'm telling.
Actually, ma'am, we have already done in practical classes.
Yes,
we have done.
Yeah,
just a big revision for us. So that's what I wanted.
Okay, no problem. We will do that.
And also we have done, like some ma'am has explained already. I have also completed.
Okay, no problem.
Only that the branch instruction we have not done because we did not use that in programming. Like
see how the branch instruction will work, all these branch instructions, they will have, see, jump on 0. Jump on 0 means when you are performing compare operations, A is greater than B, or A is less than B, or A is equal to B. These are the 3 different criteria there when you are comparing. And for A is greater than B, or A is less than B, or A is equal to B, some flags will change the state. Flags, all the instructions, in fact, all the instructions after execution, are you understanding? All the instructions after execution will change the status of the flags.
Yes, ma'am.
So depending upon that, the program has to take the decision. Your processor has to take the decision. And how, if we from outside, I will take numbers 10, 5 and 20. And when I am saying compare A and B, A is having 10, B is having 5. Now when I say compare A, because few instructions Now when you say add B, means it is understood that one data is in accumulator and you are adding the data which is there in B to the contents of accumulator. So similarly, compare B, when we say, it will compare the contents of accumulator with the contents of the B register. And depending upon whether it is greater than or less than, the flags will change. And depending upon that, the next instruction after compare B, it should be jump on 0 or jump on carry or jump with no carry. This is how you have worked with your largest number also.
Yes, ma'am.
What I am saying, and those of you who wanted that program, you can see that program once again. It will be something like this only. May not be exactly compare, may not be exactly jump on 0 or jump on carry. Okay?
Yes, ma'am.
So how the branch instruction is working, that depends on the earlier one also, earlier instruction also. Because see, flowchart when you are drawing, in that yes means one route, no means another route.
Yes.
Yes, it is like this. It will be like this.
Ma'am,
And
in exam we have to write all these machine codes.
no, don't write all the machine codes. See, if
Only
they are
address and mnemonics and comments is enough, or?
Address you can write, and you can write directly the program what data you are taking. If you take the data, directly take the data in the instruction. If the question is asked like take the data in the memory location, then only you have to give data in the memory location. Otherwise, easiest way is take the data in the instruction only. Are you understanding?
Yes, ma'am.
Immediate addressing mode is there, is it not, for 8085?
Yes, ma'am.
In that, the data will be given in the instruction only. Wait, I will give you one example. So when you say MVIA 05, I have taken the example from your material only. If you want, you can see page number 90. Page number 90. 90. MVIA means, if I is coming means the data is in the instruction. The simplest way to understand. If I is there, MVI means the data is in the instruction only. So if you take such instructions where data is in the instruction only, then it will be, the program also will be very small. If you take in the memory location, the same instruction in memory location will be like
load the data, LXI.
LDA 3000H. So LDA 3000H means from the memory location 3000H, you have to take whatever data is there in that location and move it to the accumulator. That is how that instruction will work. And one more point I wanted to tell you is, if you are adding two 8-bit data, it is possible that the result may be more than 8 bits.
Yes, ma'am.
Even if you do decimal addition also, let us say you are adding 90 plus 50, then the result will be 140. Is it not? Yes. So it is possible it will be more than 8 bits.
Yes, ma'am.
So in such a situation, the carry flag will be affected.
Yes,
and for the higher bits, you have to show what is the result in the memory location. So you will say lower bytes you are saving in one location, higher bytes. So whatever carry is there in the digital form, it will be either 0 or 1 only. So higher bytes also you have to save in some register or memory location. That one point you have to remember. If you are adding two small numbers, then the result will be 8 bits only. So generally, people who are correcting will also see whether that is 8-bit which you have taken, is there going to be a carry. But if you take small numbers and leave off the carry also, no problem. Then still the program will be correct if you are taking smaller numbers. Only thing is that the instructions which you are writing, they should be in a proper sequence.
Okay.
It will not be difficult, but you have to practice because you have done some lab. So keep
Yes, ma'am.
using, you keep that experience in mind, and you have to try to write the program. Don't go much in detail with the programming also. Do simple programs. Addition means 2-byte addition of two numbers of 8 bits, one UC, another UC addition of 3 8-bit number, or 1 byte, 3 1 byte. See, there is also one common mistake which students will do is bits and bytes. No, in the examination hall, that because of all those tension and all, people will mix up this. But be little careful whether it is a bit or a byte.
Okay, ma'am.
And so in the class we will see only for 3 8-bit number addition. If in the exam they are asking 5, I will show you at which point 3 has to be changed to 5, because you have to keep a counter there so that one by one number is added. Addition, since 8085 is a 8-bit processor, it will add only 2 numbers, 8-bit 2 numbers at a time. It will not do more than that.
Yes, ma'am.
So after that sum you have to add to third number. If there is a carry, then you have to say add with carry. So like this, some small precautions you have to take when you are trying to do the programming part. And as you are writing the instructions, you also have to imagine what is happening in that instructions when it is being written. Multiplication is in 8085, it is by continuous addition only. 4 into 5 means you have to add 4 5 times.
Okay.
You are not having MUL instruction in 8085. Generally, they won't ask also. They will ask either addition of 5 8-bit numbers or 3 8-bit numbers, or they will ask that pick up the largest or pick up the smallest. This also, ascending and descending, generally they are not asking. I think largest and smallest only they are asking. Subtraction, only one instruction will change. Instead of add, you have to use SUB. Then just now you said 4 programs which are commonly asked: addition, subtraction, and largest number or smallest number.
One is multiplication also.
Multiplication is by continuous addition only. So 4 into 5 means you also can do and see. 4 into 5 means you will add 4 5 times. That is how. There is no MUL instruction for 8085. Division is continuous subtraction.
Okay.
10 divided by 2 means you have to subtract 2. 5 times from, there 5 times we are saying. We have to keep on subtracting till the result of subtraction becomes 0. So there you have to check for the condition whether the result is 0 or not. So this is how small things you have to keep in mind when you are doing that. And mostly you see, I have also seen one question which is very common. I don't know about you, what is your observation. They will ask to explain how the instruction works. They will give a set of some 5 to 8 instructions, and they will ask explain these instructions. You must have seen in the older question paper.
There, ma'am.
So if you are familiar with those instructions, sometimes there is a choice also, explain or for
branch group instruction, arithmetic group instruction, like that question is there.
No, directly they will ask explain the instruction MVI A, 05. Explain.
Yes, ma'am. That also.
Like this. So you have to explain how. If they are asking write about the arithmetic instructions, means straight away yesterday's class or last week or before that I told, no, you in that group you choose some 4-5 instructions
They have been like with
and explain.
examples, you write the format you need to do.
Yes, you can do like that. So if they are asking explain logical instructions, means what are the different logical instructions and or XOR, like this you give one syntax you understand, no? Syntax of that instruction, and you tell logical instructions you can give there in common. The logical instructions, which are the instructions which perform the logical operations like and or XOR. And
Ma'am, in this, whenever they're explaining this instruction, no, they have written that how many flags it is affected, how many machine cycle it took, what is the addressing mode. Everything we need to write, or we can leave out an exam.
Addressing mode you don't write. Flags, what flags are being affected, if you write, that will be a wonderful thing. What
how
flags
many
machine cycles you don't write. Machine cycles you don't write, because that much you cannot remember. To remember the syntax and to remember what are the different possibilities like logical instruction and or XOR not, all what all it will perform, to write this much only it is more. So don't write about the machine cycle, don't write about the addressing mode which it will take. Only what instructions, what operations it will perform, and you write syntax for at least 2 syntax or 3 syntax. If time is there, if you know very well, you can write. And what flags are affected. That much if you can write, it is enough. If you are not remembering flags also, at least 1 or 2 flags are definitely, see, in all the arithmetic operations, flags will be affected. And in all the branch instructions also, flags will be affected. So you, all this systematically you have to write on the paper and then you have to prepare. Simply by reading it, you may not be able to remember, unless otherwise you have a very super memory. So electronics means there is lot of like paperwork will be there. All circuits you have to practice, block diagrams you have to practice. Don't confuse between one block and the another block diagrams. Architecture block diagrams also you are having almost 10 block diagrams. 8085 also the interfacing ICs devices which are there, they are also having block diagrams.
Memory also 4 are there.
So you have to practice all this. Without practice it will not come.
Ma'am, can you tell ma'am most important questions for us?
See, there is nothing like important, because I can only suggest you that you read 60 to 70% of the syllabus, and whatever you are reading, you should be able to answer a question from that particular topic. Your preparation should be like this, because questions we cannot say anything. If I am telling something and then it doesn't come, who will be the loser? You will be. No, otherwise also it is not possible to guess anything. At the most I can tell whatever questions you have seen the question papers, no, which I have put on the WhatsApp group.
Yes, ma'am.
So check whether those questions are from the questions which are there in your backside of the material. After each unit, there are questions on the backside. Generally, nobody will do like that, because these topics, they are very old topics. So it is possible that any question can come.
Ma'am, explain briefly about memory architectures. What we had to write?
Memory architecture is from your second block only.
That RAM, ROM, that everything we have to write.
Memory means it can be either a ROM memory or a RAM memory. Both it can be.
Those are the memory architectures. Okay. RAM, ROM.
Page
That's
number
also nice.
31, it is there.
Okay, ma'am. Okay, Chanchal, thank you.
So this is what this memory, definitely they are asking one question. It is easy
Yes,
topic.
ma'am.
You read that classification and characterization of memories. Because I was also thinking like this topic is easy, you should read. I wanted to tell you also this part. So tomorrow we will do programming.
Oh,
Yes, ma'am.
Anything more you want, you put that on the WhatsApp group so that by today night, if you put also, tomorrow it will be possible for me to tell that. Because
Yes, ma'am.
I also have to refer once.
This 7 block you will complete, no, that Pentium processor and Pentium Pro processor. Anyway.
Don't go, because Pentium I saw only one question. Don't go in that Pentium processor. It is much more, you will get confused. At the most, I am thinking compare the features of 386 to 486. Pentium, don't go. That architecture of Pentium is also much complicated. Don't go in that. Better than that is your second block. You read that second block.
Okay.
Pentium, one nice question was there. If I find, I will try to see that point and then tell you tomorrow.
Okay.
Okay. Okay, then we will stop here for today.
Okay, thank you.
But see, one again and again, I'm telling, I told in the class also, with the choice, so much choice which you are having on your question paper, you try to prepare topics among all those blocks. You try to read 60 to 70% of the syllabus such that you will be able to answer all the questions. Because with the choice, so much which is there, whichever topic you are preparing, you should be able to write the answer on that particular topic. So that is how I felt. If you can read 5 blocks also or 6 blocks, you can leave 1 or 2 in choice and prepare. No, last time I have seen students have written wonderfully all this microprocessor. Only thing is without confusion. If the block diagrams you are able to remember, from the figure you can write the answer. But you have to prepare on the paper, then that is needed. Without preparing on paper, you cannot write. Okay? Okay then.
ma'am.
Okay,
Thank you, ma'am.
we will meet tomorrow again, right?
Okay, ma'am. Thank you, ma'am.
Okay, thank you all.
Thank you.